5,000 light years from Earth, there's a structure in deep space that is not supposed to exist. It looks almost engineered. Concentric rings, spaced with an almost mechanical precision, expanding outward from a single point like ripples, frozen in the middle of spreading across a pond. And here's the part that should not be possible. This structure is not a still image. It is not a frozen snapshot of something that happened millions of years ago and simply looks the way it looks now. It is growing, right now, measurably physically expanding outward into the blackness at a speed that would circle the Earth 12 times in a single second. And the James Webb Space Telescope has now photographed it more than once, months apart, catching the structure in the act of changing shape in real time. Nobody expected to find something like this. Nobody was even looking for it. It was found essentially by accident, flagged by someone who was not even a professional astronomer, staring at raw telescope data and typing out in complete confusion, "I don't know what this is." That sentence turned out to be the opening line of one of the strangest ongoing discoveries in modern astronomy. Stick with me, because what scientists have pieced together since that moment reaches from the birth of carbon in the universe to a 130-year-old fossil record hiding in plain sight, written in dust, glowing in infrared light that no human eye will ever directly see. If you want to understand exactly what this structure is, why it is growing, and why Webb keeps going back to stare at it again and again, keep watching, because this is one of those stories where the real explanation is stranger than anything you could make up. And if this is the kind of space story you want more of, explained properly instead of dumbed down or exaggerated, go ahead and subscribe now, because there is more coming out of this same discovery that most channels have not even touched yet. Let's rewind to how this actually started, because the discovery story here is almost as strange as the object itself. In August of 2022, before the James Webb Space Telescope had even been formally handed over for full science operations, a stream of raw, unprocessed data began circulating among a small community of citizen scientists and amateur image processors who had made a hobby out of downloading Webb's public data archives and turning them into finished images before the official NASA release teams did. One of those citizen scientists, a Missouri-based image processor named Judy Schmidt, who had spent years turning raw space telescope data into detailed public images, pulled up a set of infrared exposures pointed at a star system most people had never heard of, a system cataloged simply as Wolf-Rayet 140, or WR140 for short. What she saw on her screen did not look like a star. It looked like a spiral, or maybe a fingerprint, or maybe has more than one person. Online joked at the time, the kind of concentric square pattern you'd see printed on an old pair of pajamas. Schmidt posted the image publicly with a caption that has since become somewhat famous in astronomy circles. She said she had no idea what she was looking at, tagged a few other astronomers, and admitted she assumed someone smarter than her would explain it eventually. The image spread fast. Within days, professional astronomers were weighing in, equally puzzled, equally fascinated. Nobody had built a telescope instrument capable of seeing this before. Ground-based observatories had picked up faint hints of 2, maybe 3, rings around this star system in the years prior, using older infrared cameras that simply did not have the resolution or sensitivity to see anything more. What Webb captured in that first exposure was not 2 or 3 rings. It was more than a dozen, nested perfectly inside one another, extending out from the star system in a pattern so regular it genuinely did look manufactured to the untrained eye. It took a team of professional researchers, led by astronomer Ryan Lau at NSF's NOR lab, working alongside collaborators studying the physics of massive dying stars, several more months to formally analyze what Webb had captured and explain, with actual data behind the explanation, exactly what this structure was, and how something in deep space could possibly be building rings with this kind of geometric precision without any intelligent hand involved at all. Here is where the story gets genuinely strange, because the explanation involves 2 stars that are, individually, already among the most extreme objects known to exist in our galaxy. WR140 is not one star. It is a binary system, 2 massive stars locked in a long, wildly elongated orbit around a shared center of gravity, located in the constellation Cygnus, a little over 5,000 light years from Earth. One of the 2 stars is what astronomers call a Wolf-Rayet star, named after the 2 French astronomers who first identified this class of object in the 1860s. A Wolf-Rayet star is essentially a massive star nearing the end of its life, one that has already blown away its outer hydrogen envelope entirely, exposing the hot, dense, heavier elements underneath and blasting them outward in a stellar wind more powerful and more violent than almost anything else in the observable universe, moving at speeds that can exceed 1,000 miles per second. The second star in the system is a hot blue supergiant, sometimes classified as an O-type star, itself among the most massive and luminous kinds of stars that exist, also driving its own powerful stellar wind outward into space. Individually, either one of these stars would already be considered an extreme object worth studying. Together, locked into an orbit around each other, they become something else entirely. Their orbit is not circular. It is a long, stretched-out ellipse, and for most of that orbit, the two stars are separated by enormous distances, farther apart than Pluto is from our Sun. But roughly once every 7.93 years, their orbital paths bring them close together into what astronomers call periastron, the point of closest approach. And when that happens, something extraordinary occurs. The two ferocious stellar winds, each one already up, powerful enough to strip material off a star, collide directly into each other. The impact compresses gas at the collision point to extreme densities and temperatures. And in that narrow window, lasting only a few months around each close pass, the conditions become just right for carbon atoms in the colliding gas to condense out of the plasma and form solid dust grains, essentially smoke forged directly out of stellar wind collision in a process that, under any other circumstance, simply could not happen this cleanly. That single fact, dust only forms during the brief window when the stars swing. Close together is the key to understanding why the structure looks like a set of rings instead of a continuous cloud. Every 7.93 years, for a few months, the system manufactures a fresh shell of dust. Then, the stars swing apart again, the winds separate, the conditions needed for dust formation disappear, and the system goes quiet for years until the next close pass. Each new shell of dust that forms gets carried outward by the pressure of the stellar winds and by the pressure of starlight itself, expanding away from the system like a smoke ring blown from a mouth, only to be followed years later by the next one and the next and the next. Over decades, this produces exactly what Judy Schmidt saw in that first raw image and exactly what the follow-up research confirmed. Not a single cloud of dust, but a stack of individual, distinct rings, each one a fossilized snapshot of one specific orbital close pass, nested inside each other like the growth rings inside a tree trunk. Except instead of recording years of tree growth, each ring in this structure is a direct record of one specific moment, decades ago, when two dying stars swept past each other and briefly, violently manufactured smoke. When the full analysis was published in a paper in the journal Nature alongside a companion paper in Nature Astronomy, both released on October 12, 2022, the numbers involved turned out to be even more extreme than the image alone suggested. Researchers counted at least 17 distinct resolvable dust shells in Webb's imagery, and the outermost of those shells, still faintly detectable, corresponded to dust that had been produced roughly 130 years earlier, meaning Webb was looking at a physical, dust-based timeline stretching back to the late 1800s, before either World War, before commercial flight, before radio existed, sitting there in space, quietly expanding outward this entire time, completely unnoticed by anyone on Earth until an infrared space telescope with modern instrumentation finally turned its mirror in the right direction. The full structure was measured to extend outward from the central binary star system across a distance of roughly 70,000 astronomical units, meaning 70,000 times the distance between the Earth and the Sun. To put that scale into perspective, that is more than a full light year of physical space, an enormous, sprawling structure of nested rings that dwarfs every other known dust-producing binary star system of its kind. Researchers who studied similar Wolf-Rayet binaries, systems that also produce carbon-rich dust through the same colliding wind mechanism, found that WR-140's dust shells extend at least 4 times farther than anything else previously documented. This was not simply an unusual object. It was, and remains, the most extreme known example of its kind anywhere in the galaxy. But the composition of the dust itself turned out to matter just as much as its scale. When Webb's instruments broke the light from these rings down into its individual wavelengths, a process called spectroscopy, they found signatures consistent with carbon-rich aromatic compounds, essentially organic, carbon-based molecules, similar in family to compounds that some researchers believe played a role in the earliest chemistry that eventually led to life on Earth. Researchers studying the second dust shell out from the star system confirmed that these carbonaceous grains had survived intact for at least 130 years, sitting directly in the blast radius of 2 of the most violently radiating stars known to exist, bathed continuously in extreme ultraviolet radiation and punishing stellar wind, and the dust held together anyway. That detail matters more than it might initially sound like it should, because one of the long-standing open questions in astrophysics involves figuring out exactly where the earliest solid dust and organic material in the universe actually came from. Material that eventually goes on to become part of the raw ingredients for new stars, new planets, and potentially new chemistry capable of supporting life somewhere down the line. Evolved dying Wolf-Rayet stars, especially ones locked into tight colliding wind binaries like WR140, are now considered one of the strongest candidates for where at least some of that very first generation of carbon-rich cosmic dust actually originated, seeded outward into the surrounding galaxy one violent periastron passage at a time, one ring at a time, for as long as these systems continue to exist. And then, in January of 2025, NASA released something that took this discovery from a static, if extraordinary, snapshot into something genuinely unprecedented. Researchers led by Emma Lieb and Jennifer Hoffman at the University of Denver, working again with Ryan Lau, went back to Webb's archive and pulled a second set of observations of WR140, taken roughly 14 months after the original 2022 images. And when they lined the two images up and compared them directly, frame by frame, they found something that had never been directly measured before in a system like this. The dust had moved, visibly, measurably, in just 14. In just months, the individual rings had physically expanded outward, each one shifting position in a way that was consistent across the entire structure. When researchers calculated the actual speed required to produce that amount of movement in that short a window of time, the number that came back was almost hard to process intuitively. The dust in every single shell, from the newest ring closest to the star system out to the oldest, faintest shell more than a century old, was moving outward at very close to 1% of the speed of light. That works out to somewhere in the range of 6 million miles per hour. Material blown outward from two colliding stellar winds, then further accelerated by the sheer pressure of Starlight itself, still carrying that velocity outward across light years of empty space, still expanding, still growing right now while you are watching this. NASA released the comparison as a short video, fading directly between the 2022 and 2023 observations, and watching it is genuinely one of the strangest things you can see in modern astronomy, because it does not look like a still photograph of a distant, unchanging object. It looks like something breathing, something alive. In the loosest physical sense of the word, visibly pulsing outward on a timescale a human being can actually perceive within their own lifetime, which is almost never true of anything this far away in space. That speed measurement also confirmed something else, something that connects back to a genuinely fundamental question in physics. For decades, scientists have understood, in theory, that light itself carries momentum and that sufficiently intense radiation pressure, the literal physical push of photons streaming outward from an extremely bright source, should in principle be capable of physically shoving matter through space, the same basic principle that makes solar sails a theoretically viable form of spacecraft propulsion. But directly observing that effect happening in real time at this scale, acting on real physical material, had never actually been done before WR140. The 2022 Nature paper describing the original ring structure specifically credited the extreme luminosity of the two central stars, both far brighter and hotter than our own sun, with providing enough radiation pressure to explain the outward acceleration of the dust shells beyond, what stellar wind alone could account for. In other words, WR140 did not just hand astronomers a strange-looking ring structure to puzzle over. It handed them the first clean, direct observational proof that starlight alone is physically capable of pushing solid matter through space over interstellar distances, a concept previously understood mathematically but never actually watched happening to real material in real time, until Webb pointed its mirror at exactly the right binary star system at exactly the right moment in its orbital cycle. Take a moment and actually picture what is happening at the center of this structure, because the raw physical violence involved is almost difficult to hold in your head properly. Two stars, one already stripped down to its dying, exposed core, both roughly the mass of dozens of suns combined, swing toward each other across an elliptical orbit that stretches out for years at a time. As they approach their closest pass, their stellar winds, gas moving at speeds that would let it cross the entire continental United States in under 4 seconds, slam directly into one another. The collision point becomes a superheated, compressed shockwave, hot enough and dense enough for individual carbon atoms to bond directly into solid dust grains out of what is essentially still ionized stellar plasma seconds earlier. That dust does not linger. It gets caught immediately in the outward blast of stellar wind and the relentless pressure of starlight. From two extremely luminous stars, and it gets thrown outward into interstellar space at speeds that make almost every human-made object we have ever launched look motionless by comparison. Voyager 1, the fastest and most distant spacecraft humanity has ever built, moves at roughly 38,000 miles per hour. The dust in WR140's rings moves at over 6 million miles per hour, more than 150 times faster. produced not by rocket engines or gravitational slingshots, but by nothing more than the raw physical pressure of two dying stars breathing violently on each other once every 8 years. So what happens next? Because the truth is, WR 140 is not a one-time event that astronomers photographed once and moved on from. It is an ongoing, actively monitored target, and the next preastron passage between the two stars, the next close approach capable of producing an entirely new ring of dust, is expected to occur again within the coming years, following the same 7.93-year orbital rhythm the system has apparently followed for at least the last 17 cycles that Webb has already documented evidence of. Every time that happens, researchers get another opportunity to watch the entire process unfold, essentially in real time, comparing fresh Webb observations against the previous ones, refining their measurements of exactly how fast the dust accelerates, exactly how the radiation pressure from the two stars interacts with the expanding shell, and exactly how much carbon-rich organic material this single system is capable of injecting into the surrounding galaxy over its lifetime. Some of the researchers involved in the discovery have pointed out that a system like WR 140 could plausibly generate tens of thousands of individual dust-producing events like this over the full remaining lifetime of the Wolf-Rayet star before it eventually ends its life, likely in a supernova explosion, potentially collapsing further into a black hole or neutron star and scattering whatever remains of the system's carbon-rich material outward in one final catastrophic event. Every ring currently visible around WR 140 is, in that sense, a preview. A small-scale, repeatable demonstration of the same basic process, stellar material converted into solid dust and blasted outward into the galaxy, that on a larger scale is thought to be one of the primary ways heavy elements and organic compounds actually get seeded into the interstellar medium in the first place, eventually becoming part of the raw material that forms entirely new stars and new planets somewhere else, sometime later. And here is the detail that tends to be the most unsettling once people actually sit with it. WR 140 is not unique because this process is rare. It is unique because it happens to be close enough, bright enough, and oriented in exactly the right way for Webb's instruments to actually resolve the individual rings cleanly. Astronomers already know of other Wolf-Rayet colliding wind binaries out there producing dust through the exact same mechanism, systems like WR 137, which is already being studied by some of the same research teams using different Webb instrument modes specifically designed to detect fainter dust structures too subtle for standard imaging to pick up. It stands to reason that the same fundamental process, massive dying binary stars manufacturing rings of carbon-rich dust and blasting them outward at extreme speed using nothing but stellar wind and starlight pressure, has likely been happening quietly across our galaxy and countless other galaxies for as long as massive binary star systems have existed at all. Most of those systems are simply too distant, too faint, or too poorly aligned with Earth's line of sight for any instrument currently available to actually resolve their structure the way Webb managed to resolve WR 140's. Which means that what looks, at first glance, like one bizarre singular anomaly sitting 5,000 light-years away might actually be a small, visible sample of a process that has been quietly building and seeding material throughout the galaxy since long before our own solar system ever formed, one that current instruments are only now, for the very first time in the history of astronomy, actually capable of watching happen in real time. It is worth pausing on just how differently this discovery reached the public compared to almost every other major Webb result. Most headline discoveries from this telescope arrive through the normal channel, a scheduled observation, a peer-reviewed paper, a coordinated press release timed carefully by NASA's communications team. WR 140 arrived sideways, through a citizen scientist scrolling through publicly archived data months before any official announcement existed, posting a confused caption to social media because she genuinely did not know what she was looking at. That is worth remembering, because it means the discovery almost happened by accident, buried in a massive public data archive that anyone with an internet connection is technically free to search through. Webb generates far more raw data than the professional teams assigned to any single observation program could ever fully examine on their own, and NASA deliberately releases most of that raw data publicly, specifically because a global community of hobbyists, amateur processors, and curious outsiders has repeatedly proven capable of noticing things. Trained specialists working through a narrower, more targeted analysis pipeline might otherwise pass over. WR 140 is arguably the clearest example yet of that system working exactly as intended, and untrained eye spotting. Something so strange it forced professional astronomers to stop, look closer, and eventually rewrite what they understood about how starlight interacts with matter across interstellar distances. There's no funded mission planning to send anything closer to WR 140. There does not need to be. The entire reason. This discovery keeps unfolding in new ways is precisely because nothing needs to physically travel there at all. Webb simply has to look, periodically, patiently across the years, and the structure itself keeps handing back new information every single time. A snapshot from 2022 that nobody could fully explain. A second snapshot, 14 months later, that revealed the entire structure was measurably, physically expanding, moving fast enough to prove, for the first time in recorded scientific history, that starlight alone can shove solid matter across interstellar distances. And now, an ongoing monitoring campaign, watching, waiting for the next periastron passage, the next ring, the next chance to catch two dying stars in the act of manufacturing the same kind of dust that may have helped build the raw material for planets and possibly life, somewhere out there in the galaxy, long before anyone on Earth existed to look up and wonder what it was. Think about what that actually means for how discovery works in this new era of astronomy. It used to be that a finding like this could only ever come from inside the walls of an observatory, from a professional with years of training and privileged access to the instrument itself. Webb quietly broke the model within its first year of operation, and WR-140 is the proof. A structure spanning more than a light year of space, moving fast enough to prove a decades-old physics prediction correct, sitting there in a public data archive, waiting for anyone curious enough to look. The rings are still out there right now, expanding, moving outward at 6 million miles per hour while you finish watching this video. Webb is still watching. The next close pass between these two dying stars is still coming, and when it happens, there will be one more ring added to a structure that has already been quietly growing for over a century, completely unnoticed, until a telescope finally arrived that was capable of seeing it properly. If you want to be here when the next observation comes in, when Webb catches this system again, and we find out exactly how much the structure has grown since the last time anyone looked, subscribe now and turn on notifications, because this is exactly the kind of real, ongoing, verified discovery this channel exists to cover, without the exaggeration, without the clickbait explanations, just what the data actually shows. The structure is still growing, Webb is still watching, and we will be watching right along with it.